Hello everyone, it is officially Falcon Heavy test launch month. Even if it gets scrubbed by a few days, it might not exactly get launched in January, but it will still be within the next 30 days. SpaceX has officially released drone footage of their Falcon Heavy waiting on the pad, still being prepared and tested. And today I'm going to talk about how far the Tesla Roadster mounted on top of this Falcon Heavy might actually get. Now, first off, for everyone complaining about how useless this payload is, you need to do test flights with new rockets, and you don't want it to be an essential or expensive or important satellite on top. The more common payload for such early test launches would be a solid slab of steel or concrete, so I think this is a little bit cooler and it's not really hurting anyone. Now the early statements were that this Tesla was going to Mars, which was later put a bit more precise, as in it would fly by Mars, because some people thought it was going to land, which is obviously not gonna happen. They don't have a lander yet. So it's going to fly by Mars, probably not too closely, but with a little bit of distance, and then stay on a solar orbit. It would keep orbiting the Sun in a sort of elliptical Earth-Mars transfer orbit, probably slightly deformed by the gravitational acceleration by flying by Mars. Then, as some people pointed out, the Mars transfer window hasn't really begun yet. The 2018 transfer window begins in April, so it's still a little while away, and if you don't really understand the actual orbital mechanics behind this and you just look at that, it seems like it's not gonna get to Mars because there's no transfer window yet. However, you have to think about what a transfer window actually is. Now, there is in the constellation of Earth and Mars one specific point which is optimal for transferring to Mars. This optimal point shifts a little bit around because the ratio of the Mars and Earth orbital period is not a very round number, so the position of the constellation with the transfer window, that transfer window is shifting through the year, and so Mars and Earth will be at different positions relative to their periapsis and apoapsis, and so some transfer moments have Mars and Earth a little bit closer or a little bit further away, so some are a little bit more or less optimal, but those are really tiny differences. What's important for now is that around each 2.25 years there is one moment where it is, at least for this span of time, optimal to transfer from Earth to Mars on a close to Hohmann transfer orbit. Of course, the Hohmann transfer orbit would assume that you go at periapsis and apoapsis, which isn't really an option, but you can still go on a close Hohmann trajectory where it is relatively optimal to transfer. The optimal way, of course, being that you burn directly from low Earth orbit to transfer trajectory. But now we still have to ask, what is a launch window? Because there is really just one optimal moment. But of course, this is not really a sudden jump. There is a very slight, and the actual mathematical description of how much the required delta V varies over time is a bit complicated, but it's somewhat parabolic, so it ends up as a rather flat graph at the point of optimum. So if you just miss that optimal point by a little bit, then you only need a tiny little bit more delta V. So what we've done is we've defined a transfer window around this optimal point, which is a honestly more or less arbitrarily defined window during which you need only negligibly more delta V than at that optimal point. And this is really important because, as I said, these are somewhat arbitrarily defined. We've taken 4 months around that optimal transfer point, 2 months before it and 2 months after it, and we've said that this is a reasonable window. It's long enough to reliably plan missions within that window and not have to scrub them for a few years just because you missed it at the exact right second. And in terms of orbital mechanics and fuel use, it's still close enough that we've said, okay, this is a reasonable time to launch a Mars mission and launch a Mars rover or something, and not waste a lot of fuel on it, which makes sense for a tightly budgeted mission with a heavy spacecraft, a lander, and a limited Delta V. But then this is a test flight, and the Falcon Heavy has plenty Delta V, so that possible launch window actually extends quite a bit. We don't have to launch within that reasonable launch window because the Falcon Heavy doesn't have to fly optimally. It has a lot of fuel to spare. It's not an optimized mission. It's a test flight, and the payload is incredibly lightweight for a Falcon Heavy. If you look at the SpaceX website, for the Falcon Heavy it lists a payload to low Earth orbit of 63.8 tons, to geostationary transfer orbit of 26.7 tons, to Mars of 16.8 tons, and even to Pluto of 3.5 tons. That is still a lot more than a Tesla Roadster. These numbers are for an expendable launch, and the test flight will be reusable, or the boosters will all be landed. The outer boosters will boost back and land at Cape Canaveral. The center core will land on a drone ship. So that takes a little bit of fuel, and it means that it has a little less payload. But we know roughly how much, and actually while there isn't very much specific data published about the Falcon 9, we know about how heavy the second stage is. We know how Delta V impacts the payload capacity. We have published data for payload capacities to geostationary orbit, fully reusable, and we can extrapolate that to Mars and still get much more payload than a Tesla Roadster. It's probably not gonna get all the way to Pluto fully reusable, not even without any payload, but it's still gonna go quite a way beyond Mars, and that widely extends the transfer window it has. The precise optimization behind this is a little bit tricky, but if you go on a very elliptic orbit with a periapsis even below Earth's orbit, you can use your Delta V rather efficiently, and with a little bit more Delta V you can extend the transfer window quite a bit. And it is coming up in 4 months, which is a little bit away, but then in terms of transfer windows, not that far away. It means the Earth-Mars constellation is off the optimal point by about 60 degrees, and you can correct that. A Tesla Roadster is listed at about 1.2 tons. The mounting mechanism and other additional mass is mostly already in the payload capacity calculation in the second stage mass. So it might be 100 kilograms more or so, but that is about 1/3 of the Falcon Heavy's listed payload to Pluto. And even in fully reusable mode, it's still less than 1/4 of the payload to Mars at an optimal transfer window. So they have enough Delta V left, which of course also means that the orbit might look a bit different than normal Mars transfer orbits, and might even mean, if they do it right, that they could fly by Mars several times. They might also do a bit of a gravity assist by Mars, and then they could have an orbit with an orbital period exactly half that of Mars, so they could fly by Mars on a regular basis, but I'm not sure if they're going to do that. Probably not. Still, this Falcon upper stage and this Roadster might very well fly by Mars. How likely it is to actually succeed is another question, which I should make another video about if I find the time for it. Of course, this also brings us to the slightly more joking questions. If a Roadster plays Space Oddity in space, where no one can hear it, is it still playing Space Oddity? And what does Elon's car insurance say about this? Now, Elon's car insurance is probably already a little bit more expensive after his anecdote he told in an interview, or I'm just gonna say watch this, but I'm pretty sure this specific Roadster is no longer insured anyways, and even if car insurance usually doesn't cover accidents happening while loading a car on a rocket and launching it to Mars, that's not really standard operation. So jokes aside, I hope I'll get around to make a video about the probability of this launch succeeding or not. It is an early test launch, but it might still be a bit more reliable than other early test launches. If I then still got time, I might look more detailed into the trajectory that this Falcon Heavy would likely take if it goes to Mars at this moment. I hope you found this somewhat interesting, and as always, thanks for watching.